The last lesson in Chapter 12, Working with Rational Expressions, is to solve equations that have fractions, big fractions. So we're going to solve rational equations. And if you have one equation on each side of the equal sign and they have a common denominator, effectively you can just cross off the denominator and solve the equation that's left. And the reason that that works is because what we're really doing is multiplying each side by x plus 2. And of course we're allowed to multiply an equation by the same thing on both sides. And then what happens is the x plus 2's cancel each other out in both the numerator and the denominator. And then we're just going to be left with this 6x equals negative 2. And then we'll divide both sides by 6 and say that x is negative, well, we could say negative 1/3 or negative 0.3 repeating. So going back to the beginning, instead of writing that out, instead of showing that I was multiplying, if you see a common denominator on both sides, you can just cross it off and then solve the rest of the equation. So in this case, I just know right from the beginning, the denominators cancel out and negative 5 equals x. That's the whole thing. Okay, but in this problem, the denominators don't match, so we need to get them to match. So just like we did with adding or subtracting, I'm going to look at the parts. This has a 3 and an x, and then this has the 2x minus 5. So it needs the 3 and the x, and then this side needs the 2x and the minus 5. So I'll have to multiply by 2x minus 5 on the top and the bottom, and then here I'll have to multiply by 3x. And now the denominators are common denominators, so now we can cancel out the denominators. So I'm doing 2 times the quantity 2x minus 5 equals 3x times the quantity x plus 3. And in this case, I'll show you when this does and doesn't work, but we already knew how to solve this earlier this year because we could just do cross products and see that's what we would be getting this problem. And then if we did cross products this way, we would be getting this problem. And that's actually why cross products work, because what you're really doing is giving the fractions a common denominator and then getting rid of the denominator. So I'll distribute and get 4x minus 10 equals 3x squared plus 9x. And then we need to get everything on one side. So we'll have 0 equals 3x squared plus 5x plus 10. And that does not seem like it would be factorable. And it is a quadratic equation. So we're going to have to probably use the quadratic formula. Maybe it's factorable. I guess we could just check and see 1 and 3, 1 and 10, and 2 and 5. And we're trying to get a 5 in the middle. It's not. I don't think it's factorable. Okay, so it's worth at least thinking about because it takes a little bit of time to do the quadratic formula. All right, so quadratic formula, we have A equals 3, B equals 5, and C equals 10. And the quadratic formula is it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we'll have negative 5 plus or minus the square root of 25 minus 4 times 3 times 10 all over 6. And now I'm going to do the square root part. I'm just going to do this part right here. The square root of 25 minus 4 times 3 times 10, it's not going to work because 25 minus 4 times 3 times 10 inside of the radical sign is a negative 95 in here, and you can't take the square root of negative 95. So this whole equation has no solution, so we would say it does not exist. Okay, let's try another one. All right, so this one has 3 parts, and the first denominator is x plus 5, this denominator is x plus 2, and this denominator is a 1, and we need to get all 3 of them to match. So this needs the x plus 2 on the top and the bottom. This needs the x plus 5 on the top and the bottom. And the 6 actually needs both parts. I really don't even have any room to write it, but it would have to have both parts on both the top and the bottom. So let's straighten out what we really have. Once we do all of that, we have common denominators, so everywhere. Every fraction has the same two binomials, so we can just really forget about the denominators. Get rid of all of those. And then in the numerators, there's 3, left over from 3 fractions. So we have that foiling problem, and then we have 6 with the x plus 2 and the quantity x plus 5. And then it equals -2 times quantity x plus 5. Okay, that's where we're at. So I'm going to FOIL over here and get x squared minus 1x plus 2x would just turn into 1x minus 2. And then here I'm going to, I guess I'll FOIL first. So I would get x squared plus 5x plus 2x is 7x plus 10. But then I still have to multiply all of that by a 6. So it would become 6x squared plus 42x plus 60. And on the right-hand side, I'll distribute the -2. All right, now we want to put all of this together. So here we have 7x squared. So we're done with those. And then we have 43 x's. But then we're also going to add 2 x's over here. So that would be 43, 44, 45 x's. And we're done with that, and that, and that. And then we'd put together these like terms and have 58. But then we're also going to be adding this 10. So that would be plus 68 equals 0. Maybe it's factorable. I'm not sure. I can just try. So let's see. We would be using 1 times 7, and then we could do 1 times 68, 2 times 34. 3 doesn't go in there. 4 times 17. 5, 6. I think that's it. Okay, so, and we're trying to get 45 in the middle. Maybe 28 and 17. Yeah, that adds up to 45. Okay, so factoring, we could use x and 7x. We want to multiply the 7 by the 4 to get the 28x right there. And we want to multiply the 1 by the 17 to get the 17x. And everything is positive. Well, at least everything is positive. Okay. This problem has a lot to it. So now the factoring's done, and now we can just give the solutions. So we just want to say what would make these parts equal to 0, and it would be, x could be -4, or we're trying to make this part 0. So remember how this works, we would just move the 17 over, which makes it negative, and then we would divide it by the 7. So we'd have x equals -17 over 7. And then we'd have both of those answers. Okay, let's keep going. All right, this one doesn't look quite so bad because, well, not really. Okay, so, because every fraction at least has one of the parts. So the first fraction is missing the x minus 2. Put it on the top and the bottom. The second fraction is missing the x minus 4. And then the third fraction is missing the x minus 4. Okay, so now all the fractions have the same pieces. We can get rid of them. Be really careful not to lose that negative, though. It's going to go on the 5. So here's what we have. In this first fraction, on the top, we still have an x times the quantity x minus 2. And then for this fraction, we have a -5x times the quantity x minus 4. And then we have equals, and then for this fraction we have negative 18 times the quantity x minus 4. So we'll distribute and get x squared minus 2x minus 5x squared plus 20x equals negative 18x plus 72. Okay, so 1x squared minus 5x squared is negative 4x squared. I'm going to add the 18x's over here. So that would be 38x minus 2x would be 36x. And then I'm just going to subtract the 72. It's a quadratic equation again. I think those are all divisible by 4. So I would do that for sure to make the numbers a little smaller. Maybe even divide by negative 4. So now we would have x squared. And then this part would become negative 9x. And then this part would become positive 18. Okay, then we could factor this. We'd have x minus 6 and x minus 3. And that means the solutions would be x equals 6 and x equals 3. And there's one more. Okay, so this one, oh yeah. Okay, so we have b plus 3, and then here we're going to factor this, and we would have b plus 3 and b plus 9. And then this fraction just only has a 1. So our first fraction needs the b plus 9, numerator and denominator. The middle fraction needs both parts. It needs the b plus 3 and the b plus 9. And also it needs it on the denominator, b plus 3 and b plus 9. And then the fraction on the right-hand side has both pieces. So once that part's done, remember we can just ignore the denominator. From our first fraction, we just get b plus 9. We're timesing it by 1. Our second fraction is a little more complicated, this one. So what I have in there is I need to FOIL. Well, I have a 2 times b plus 3 times b plus 9. And then equals b squared minus 3. Okay, so we have to work on this part. I'm going to FOIL and get b squared plus 9b plus 3b is 12b. And 3 times 9 is 27. And then we still have to double all of it. So we have b plus 9 plus 2b squared plus 24b plus 54. And then we just want to get everything on the same side. So I'm going to subtract b squared, and we'd have 1b squared. We're done with those. And then these b's can go together and make 25b. We're done with those. I'll add the 3. So that would be 57, but then also plus 9, 66 equals 0. And then I don't see any way we could factor that. Oh, yes, I do. Okay, so if we looked at the possibilities, it's going to be that 3 times 22. So we're going to factor this into b plus 3 and b plus 22. And then our answers will be negative 3 and negative 22.